Welcome! This video on limits is brought to you by the Learning Center at Vancouver Community College. Visit our website at www.vcc.ca/tlc for more information. We're looking for requests, so please submit your suggestions to mathsciencetutor@vcc.ca. The question asks us to evaluate a series of limits. Most functions form smooth curves when you graph them, such as the cubic function here. In these cases, the limit does not have a different value from the function. There's no problem with plugging 4 into this expression, so that's how we determine the answer. Limit problems only become interesting when it's not possible to plug in. If we plug 4 into this rational expression, we get 0 over 0. Which is a signal that this expression can be simplified. We factor the numerator. The fact that we're evaluating a limit as x approaches 4 implies that the value of x never reaches 4, and as long as x is not 4, we're allowed to cancel x minus 4 from this fraction. That detail, that a limit never reaches the value that it approaches, is important. For this piecewise function, it doesn't matter what value is defined for x equals 4. The limit always looks near x equals 4. This function behaves like y equals x minus 1 everywhere else, so the limit of this function is 3. So what happens if the function has different behaviors above and below 4? We can use one-sided limits in that case. The right side limit looks at values slightly greater than 4, so we use this piece of this function. Then the left-sided limit looks at values slightly less than 4, so we use the other piece of the function. If the two sides don't line up, then the limit doesn't exist. That's the basics of limits. If you'd like more detailed information and some practice problems, look for the Limit Problems worksheet for Math 1100 on our website, vcc.ca/tlc.